Hey y'all, in this video we are going to look at constructing functions to model linear relationships. Our I can statement is I can write an equation in the form of y equals mx plus b to describe a linear function. So nothing really new, but we are looking at it in the context of some real-world problems. Remember that y equals mx plus b is the slope-intercept form of a line. In the equation, m represents the slope and b represents the y-intercept. Our essential question is, how can you use a function to represent a linear relationship? In example 1, we're going to look at writing a function from a graph. A plan for a skateboard ramp shows that the plywood for a triangular sides of the ramp should be cut such that for every 9 inches of height, the triangle should have a base that is 33 inches long. What is the height of the skateboard ramp shown? So the skateboard ramp is 110 inches long. What will the height be? We can graph this representation and determine the slope. So we see in this graph, every 9 inches we go up, the graph goes over 33 inches. Up 9, over 33. This is the slope of the line. It's the change in height divided by the change in the base. So up 9 over 33. We can divide both those numbers by 3. 9 divided by 3 is 3, and 33 divided by 3 is 11. So our simplified version of the slope is 3/11. We can then use that slope to write an equation that represents the function in the graph. We'll use the equation to find the height for a base of 110 inches. So here's how we write that equation. Y equals 3 over 11x. That's not new. But we want to make sure we know what each thing is. Y will be the height, since that's what we're trying to find. The slope is 3/10, and x will be the base length that we plug in to figure out the height. So we plug in 110 for x. 110 times 3 over 11 is simply 30. Do this with a calculator. So the height of the ramp is 30 inches. That's going to be about 2.5 feet tall. You try it. How will the height of the ramp change if the plans show that for every 3 inches of height, the triangle should have a base that is 15 inches long? So again, figure out the slope of the function, plug that into the equation, and again, if the base is 110 inches, plug in 110 to your equation, then the height of the ramp will be how many? In example 2, we're going to look at interpreting a function from a graph. So the graph shows the relationship of the height of a burning candle over time. What function represents the relationship? So in this graph, we can see the initial height where it starts. We can see the rate of change down 1 over 1. This is representing a relationship. And we can see the final value, the time when the height of the candle hits 0. The situation, the relationship, is that the candle gets shorter as it burns. That makes sense. The end result is after 10 hours, the candle will be burned out. The initial height of the candle is 10 inches, and the candle burns at a constant rate of 1 inch per hour, 1 over 1. This means that because we're going down, we'll have negative 1x plus 10, our y-intercept or our starting value. This function represents this relationship. So the important pieces is where it starts and the rate at which it goes, or the slope. You try it here. The graph shows the relationship between the number of pages printed by a printer and the warm-up time before each printing. What function in the form of y equals mx plus b represents this relationship? So we have number of pages listed along the bottom and time listed along the top. You'll want to find your slope to plug in for m and identify your y-intercept to plug in for b. Our final example has us writing a function from 2 values. The cost to manufacture 5 toys is $17.50. The cost to manufacture 10 toys is $30. Construct a linear function in the form of y equals mx plus b that represents the relationship between the number of toys produced and the cost of producing them. So we can determine our constant rate of change, figure out what is the price per toy. So we can take 30 minus 17.5 over 10 minus 5. We'll get 12.5 over 5, which is 2.5 over 1. This means that each toy costs $2.50 to make. We'll use the slope and one set of values for x and y to find the y-intercept. So we start with an equation. We have $30 and 10 toys, and we see our slope of 2.5. So 30 equals 2.5 times 10 plus b. 2.5 times 10 is 25, and so essentially we're asking what plus 25 equals 30. So that is how you can see that they came up with the initial value or y-intercept of 5. So that means that even if they make 0 toys, the cost to manufacture, the cost to have the lights on is $5 in this situation. So the function that models the relationship is y equals 2.5x, because 2.5 is our unit rate or our slope, plus 5, which is our initial value. Here's one final problem for you to try. Jin is tracking how much food he needs to feed his dog each week. After 2 weeks, he has used 8.5 cups of dog food. After 5 weeks, he has used 22.25 cups. Construct a function in the form of y equals mx plus b to represent the amount of dog food used, y, after x weeks. So remember to first find the unit rate, how many cups per week, and you can do that by taking the 5 weeks and subtracting the 2 weeks information. Because the cups or the dog food is y, you'll do the cups subtracted on top and the weeks subtracted on bottom to figure out your unit rate. Then, using one of those weeks of information, you can figure out what is the initial value for b, and finally write your equation. To summarize, a function in the form of y equals mx plus b represents a linear relationship between two quantities x and y. In the equation, the slope or the constant rate of change is always m, and your y-intercept or your initial value is always b. Your next steps are to turn in your 4.4 notes, complete your build 4.4, and take your 4.4 mastery check. Then continue on to the next lesson. Good luck!